Hello and welcome. In this session, we will have a basic understanding on variables and memory in C program. As a note, there is a detailed explanation of how memory is organized in Linux system and how C programs use the memory layout in Linux systems. The main intention of this session is to give a basic overview of how different memory segments are organized and what are the memory address and how variables and its data are stored in memory. From this slide, we can see how different memory segments are organized. We have code or text segment in below, followed by data segment. This will have further initialized and uninitialized data segment. The heap grows upwards starting from lower memory while stack decreases downwards starting from higher memory during the code execution. Care should be taken to make sure the stack variable does not enter the heap segment. If this happens, then stack overflow occurs. Also, as an important note, both stack and heap grows or shrinks dynamically during code execution, but data segment and code segment usually does not grow or shrink during program execution. Variables. In C programming, variables are memory locations that are named and are used to store data values. Variables occupy different memory segment like code segment, data segment, stack segment, heap segment based on how they are created. Variables serve as placeholders for value that can change during the execution of the program. Variables are declared with a specific data type. This means variables can store only particular type of data. We will discuss more on data types in next session. In this example, we have used int and char data types. Count is a variable and can store data of data type integer. Integer variables in Linux systems consumes 4 bytes of memory. Similarly, input is a character type variable and is used to store only characters. Character variables take 1 byte of memory. Now, here in the slide, we will try to visualize the memory and how variables are stored. Here, each byte memory has a unique memory address. As an example, we are using 32-bit address to indicate each byte. Hence, variable input, which is of data type char, will take 1 byte, and variable count, which is of data type integer, will take 4 byte. Also, we have taken an integer with its value 0x6789abcd to store it in memory. There are two types of store data. They are Little Endian and Big Endian style. In Little Endian, the lower value byte are stored in lower memory address. Hence, 0xcd is stored in address say 0xFFFF0001. 0xab is stored in next higher address and so on. Similarly, in Big Endian, the lower byte, that is low value byte, are stored in from higher memory towards lower memory. 0xcd is stored in higher memory, 0xab is stored in next lower memory, and so on. Thank you for joining this session.